So now, next chapter we start. So chapter is from your EDD notes, chapter 9, simulation. So welcome in a new chapter. It is very good and interesting chapter. If you have the interest of the programming, you can practice for this chapter. So simulation. Any idea about what is the simulation?
Sir,
Simulation is nothing. It is the mimicry.
we mimic each process by taking large sample size and uh, taking use of random numbers.
Yes, yes. So this is the more technical definition. But if for the layman, if you want to explain what is the simulation, what is the Ram Leela? It is the simulation of the Treta Yuga, right? So it is the mimicry. So here, simulation, it is the most important technique used in analyzing the complex system in estimating their characteristics. Simulation is the technique with which you can estimate the characteristic of the complex system. The complex system of which type? For which the analytical solution you cannot give. With analytical way, you cannot determine the performance characteristics. Whenever the mathematical or analytical methods for getting the characteristic of complex system do not exist, we have studied the queuing system, inventory system, reliability theory. In every system, we have seen we have some well-defined formula, but with so many assumptions. If you make your system complex, so those basic formula, those basic approach will not work. So in such cases, we can for estimating the performance characteristic, we can use the technique of the simulation. So simulation enables one to obtain the approximate value of these characteristics. Or you can say it is a technique of manipulating the model of the system through process of the imitation. Means generally in functioning of any system, whatever the process we require, that process we generate artificially, right? That process we mimic artificially, and whatever the results we are observing, from that we estimate the performance of the characteristic, performance characteristic. We estimate performance characteristic. So that process is known as the process of the imitation or miming. So in simulation, characteristic of the systems are estimated by artificially doing large number of the sampling observation. So whatever you have told, that is correct. Here we have to do the large number of the sampling observation on the variable of the system following the condition of the system. Means we repeat, we imitate the process, we imitate the functioning of the system number of times and observe the performance characteristic, right? And here when we are repeating, when we are imitating the process, then condition should be the specific. Means for each repetition, the specific condition should not change. Then simulation is essentially technique of conducting the large number of the sampling experiment on the model of the system. Means here in the simulation we have to repeat, we have to conduct the experiment number of times. Then only you can estimate the required estimate the value of the required performance characteristics. So normally simulation involves large number of the computation. In general, we require the heavy calculation. So this simulation we have started, this technique we are using, right? We have started to use after the advent of the computer only or computing device only. So analytical method for finding characteristic of the queuing and inventory system in which some of the above conditions can be relaxed are also available. Means in the simulation, through the simulation you can determine the performance characteristic, or you can estimate the performance characteristic for the complex system under the different assumptions. The complexities of the real life may be so large that analytical solutions are not available. In such cases, simulation is used. As I have already discussed, wherever the analytical method or known mathematical methods are not applicable, there we use the this heuristic method, or depending over the randomness, we use the simulation or simulation technique. So now we will describe the basic simulation concept, illustrated them by analyzing the single queue, single server queuing system, and other simple model. So here I will demonstrate, right, how uh, we can describe the process of queuing system, single server queuing system, or other simple model, and you can extend for the other general system. The concept illustrated could be extended to the more complicated system by developing suitable computing technique. So here we have uh, some basic terms required in simulation. So first, what is a system? System is nothing. It is a collection of interacting objects. For example, queuing system. In that, servers, customers are interacting to each other. So system, it is nothing. It is a collection of interacting objects. Inventory, demand, storage, unit, item, all are the interacting objects. So collection of interacting object is known as the system. Then after entity, an object of interest for which we are talking, right? We are studying. So an object of interest in the system. For example, in queuing system, customers, servers are entity. For the inventory system, demand, item, all are the entity. Then the attribute, it is the property of an entity. For example, arrival time, distribution of the arrival time, service distribution of the service time in case of the queuing system, or number of servers, the distribution of the demand, limitation of the storage. All these are the attributes, the property of an entity. Then state of the system is determined by assigning the particular value to each attribute of its entities. So state, we can define that. For example, when we say number of customers, there are five customers, two servers, right? Two servers with limitation of the 10 customers in a room. Then after we have the another situation, there are 8 customers with 3 server, and maximum capacity is 15. So these are the state. Means for the different attributes, we are assigning the particular value. So it denote the state of the system. Then after, we have to identify the variables, each attribute of an entity. For example, number of customers, arrival rate, service rate, number of servers. These are the variables. Each attribute of an entity of a system can be represented by the variables. So we can have the two type of the variables: decision variable and state variable. The value, what is the decision variable? So the value of these variables are specified by the analyst in the beginning. So how many servers we have? What is the queue discipline? So these all are the decision variable which we have to decide before imitating the process of simulation. Then state variables describe the state of the various attribute of the system. Means how many, what is the maximum capacity, right? How the customers are arriving. All these are the state variable. Then after the activity. Now, how we can imitate? We can imitate by imitating the activity. So activity is what? Any process that can change the state of the system. For example, arrival. So with the arrival, number of customers in the system will increase by one. With the departure, number of customer in the system will decrease by one. So arrival and departure are the activity, right? Generation of the demand, replacement of the stock are the activity in the inventory system. The process that can change the state of the system is called an activity. For example, arrival of the customer, service of the customer, and so on. Event. Event is the start or completion of an activity. Means either we consider the start point or the end point of any activity as an event. Then system parameters represent the physical constant. For example, in some simulation we require the value of the g, small g, right? Design parameters of the system. Sometimes we require the specific heat constant, right? Density of the liquids. If whatever the process, accordingly we have to consider. So here we have the, for example, if we are talking for the queuing system or inventory system, we must know what is the failure time distribution, whether it follow the exponential distribution or gamma distribution or any other distribution. So because distribution is standard one, so these all will come as a system parameter. System parameter represent the physical constant, design parameter of the system. For example, interarable time distribution, service time distribution, right? Now some variables of the system, are random variable. So in this, we have the system parameters, we have the state variable, we have the decision variable. So out of these variables, some are the random. So when we have the random, so when we repeat the process, right, we have the different results, right? We have the different results. So by computing the average, by computing the average, we can estimate the required performance characteristics. So state variables are affected by the decision variable and the system parameters. So if there is any change in the decision variable or the system parameter, then definitely it directly affect the state variable also. So state variable will change, or will take the different value through the events. Events, it is what? Events or an activity. Event is what? Start or end point of the activity. So how we do, how we make the simulation model? So first we have to identify all the variables. Identify all the variables of the system and events which affect the system. Then after we have to we have to identify all the restrictions and constraint or the basic assumption, accurate assumptions and restrictions on the variable and the event of the system. Sometimes we have the restriction of the capacity, sometimes we have the restriction of the population, so sometimes we have the restriction of the rates. So that we have to identify. Then the interaction between the different variable, how the different variables are related to each other, and events of the system should be identified. And with the change in event, with the occurrence of an event, what is the change in the state variable or different variables, we have to identify that. For example, I have told you, as there is any arrival, it means there is an increase in number of customer in the system. So that interaction we must know. Building the mathematical model of the system is to identify and describe the various cause and effect relationship between the system parameter, decision variable, and the state variable, and to define and evaluate the system performance. So means we have to recognize the relation between the all type of the variables and how the one will change with the changes in the other variable. So here, what is the use of the simulation to determine the system parameter is part of the formulation of the model. In simulation, events of the model of the system are artificially generated. Means I have told you everything depends on the occurrence of the event. So that events we generate artificially, right? That events we generate artificially. So as we generate the events artificially, we have the change in the decision variable, state variable, or the system parameter, or right. So there is a change in the state variable also, and these changes we will record, which help in estimating the performance criteria or performance indices. So it is not, as I have told you, we have to imitate the process. So it is not easy task. So simulation model takes much longer to construct. For example, means if you have to generate, if you have to study the queen system, so we have to generate the servers, customers, right, artificially. So it required much more computer time, and you know, for estimating the performance indices, we have to repeat the process number of times. So for repeating, we require the good knowledge of the computer, and it takes lot of time also. So time to execute, and what is the irony here? Even with so hard work, it gives very less information. So generally, we use the simulation as a last tool, because after having so much labor, computation, time, we will get very means less information. So we use this technique for the with this technique wherever the mathematical model or analytical models are not applicable. So despite its difficulties and cost and time required, simulation is often the only practical solution of the real time problems. So as you know, for the simulation also we have the different phases. For any modeling, always we have the different phases. So first we have to formulate the simulation model, then we have to implement, right? Then design of the simulation experiment, validation of the simulation model, then we have to analyze. So these are the different phases of the simulation. That is not big deal. Now when we are when we are saying that we have to repeat the process in simulation number of times, so when we are performing the process, when we are generating the events artificially, so there is a change in the state variable, or there is a change in the decision variable and the system parameter, which governs the change in the state variable. So that changes we have to observe regularly. So when we are observing those changes, over that we have the following classification of the simulation. So we have the two type of the classification: fixed time increment and next event increment. What is the fixed time increment? Means, for example, here we have the timeline. Customers are coming randomly. Customers are coming or going, right, randomly, going, and means there we have the process of the incoming and outgoing of the customers. So In a fixed time increment, what we will do, we observe the characteristic at the fixed period of time. At the fixed period of time, we observe the characteristic. So in the first phase, we have the two customer. In the second phase, we have the one departure, one arrival. Here also we have the one departure, one arrival. Here also we have the one departure, one arrival. There is no departure, no arrival. There is only one arrival. There is only one arrival. So if you say at this point we have the two customers, at this point we have the again two customers, at this point again we have the two customers, at this point again we have the two customers, at this point again we have the two customers, at this point we have the three customers, at this point we have the four customers. But if I say what means at this point you can say number of customer is equal to 2, but you cannot say how many customers are arriving and how many customers are departing from the here. So only the number of customers you can see. So that is the fixed time increment, means after the fixed time we will observe the characteristic. But in the next event increment, for the each event, whether the departure or the arrival, I'm talking only for the queuing system, because queuing system or the inventory system, because we have covered these things. But you can apply the simulation in any system. We have a lot of use in the chemical engineering, electrical engineering, every kind of the engineering we have a lot of use. So next event increment is what means, with each increment we have to record the observation, right? For each event we have to record the, right, we have to record the performance characteristic. So that come under the next event increment. Here the observations are made whenever certain specified events take place. And in the fixed time increment, here the observations are made at the fixed increment of the time. So both approach have the advantage and disadvantage also. In the next event increment, we have to observe regularly. It means we have to present regular throughout the period. But in the fixed time increment, we have to present for the lesser time, but we miss the event or we miss the activity. So we cannot say which one is the better, which one is not better. We are not going in that, but we prefer we prefer the next event increment, because it absorbs the all activity, it records the all activity, it records the all, right? So this example I will start in next class. So here I am stopping. So it is very interesting thing. So is there any so today we have covered only the basic of the simulation. So if you feel any doubt, so platform is open, you can discuss.
Sir, has all e-checks been completed?
No, till now I have not started. Actually, last 2 days I have some webinar and some engagement. So I have not started yet.
Okay, sir. Okay. Thank you, sir.